Welcome to UGC's ePathshala lecture series on computer science. Today we are going to look at big data visualization. The learning objectives of big data visualization are: first we will look at the concepts of what big data is. Next we will try to learn some of the terminologies related to big data visualization. Next we will also learn about the different application domains of big data. And finally, we will come to know about certain examples of big data visualization. Introduction. Data visualization is a presentation of data in a pictorial or graphical format. We know this already. This enables decision makers to see the analytics presented visually, and they can easily grasp concepts, difficult concepts, or also identify new patterns from this. With interactive visualization using technology, we can also drill down into charts and graphs for more detail, interactively changing what the data we see and how it is being processed. It is intended to analyze complex data. So these kind of data which are useful for data visualization are received from either satellite photos, sonar measurements, surveys, computer simulation, or some kind of experimental analysis. So if you look at the types of data that we have, so this is a kind of data that we receive every day. Say about 12 terabytes of tweet data every day we receive. We receive about certain terabytes of the data that we try to receive every day from Google, and about 25 terabytes of log data every day from about your Facebook data set. So these are the kind of data that we receive from the social networking applications. Similar to this, we also have huge amount of data, say 30 billion of RFID tags are available in today, from which we receive lot amount of data, and about 4.6 billion camera phones are being available worldwide, from which we receive lot amount of data, and hundreds of millions of GPS enabled devices are available, from which annually people try to populate huge amount of data onto the web, and about 76 million smart meters are also available. So with all these devices and with all these social networking applications, human beings try to populate huge amount of data onto the web. So if you look at this, we call that kind of data that we receive from all those social networking applications plus the various kind of devices that we have looked at, they try to populate data onto the web, and that amount or that huge data that is available on the web, we call it as a big data. So some of the essential characteristics of big data, if we see, volume, velocity, and variety are the three most important characteristics of big data. Volume in big data doesn't sample it. It just observes and tracks what happens. Why the volume is very huge in the case of big data? It means that big data is not samples of data. It is some kind of tracking of data which happens continuously, thereby the amount of data that we receive is also very huge. Similarly, the velocity. Big data is often available in real-time applications. Most of the data that we receive are available from real-time applications, wherein they try to populate huge amount of data in real time, which amounts to the velocity of the data that we receive. Similarly, if you look at the variety, big data draws from text, images, audio, video, plus it completes the missing pieces through data fusion methodologies. So since big data tries to draw the data from various other media files, say text, images, audio, video kind of thing, the variety of data that we receive, the different types of data that we receive is also very huge. So these are considered as the essential characteristics of big data as such. So if you look at the volume of big data as such, from this figure we can see the scale of data that we receive. Say in 2020, about 40 zettabytes of data, that is 43 trillion gigabytes of data, will be created by an increase of about 300 times the data set that we have received from 2005. And about 6 billion people will have their own cell phones, since the world population may come about 7 billion. And it's also estimated that about 2.5 quintillion bytes of data are created each day, and most companies in US have at least 100 terabytes of data that is being stored. So this is a huge volume of data or a scale up of data that we try to get by, that has been predicted by the year 2020. If you look at the velocity or speed, the data is being generated fast and it also needs to be processed fast. So it is the online data analytics that is supposed to be done over the data that we receive, because late decisions may lead to missing opportunities. Some of the examples are e-promotions. In the case of e-promotions, based on your current location and your purchase history, what you like will be analyzed, and these patterns are sent for promotions right now for store that are laying next to you. Similarly, in healthcare monitoring industry, sensors are going to monitor your activities and the body, and any abnormal measurements that are being inferred require immediate attention. If you look at the variety or complexity of data, it is a relational data. It may be the data that we receive from the relational data set like tables, transaction data or legacy data, or it can be some kind of text data that we get from the web, or it can be some kind of semi-structured data which is in the form of XML file. It can be some kind of graphical data which we try to acquire from social network and semantic web. It can be some kind of streaming data where you can only scan the data once, and a single application can be generating or collecting many types of data, and or else it can be from some big public domain like online, weather, finance, etc. So these are the variety of data that we get in everyday life. So if we classify the big data visualization domains, the various big data visualization domains are classified as retail banking domain, government, insurance, healthcare and medicine, telecommunication domain, transportation, capital markets and asset management. So these are the major areas that receive huge amount of data in day-to-day activities, and we'll also look at some kind of visualization techniques that are applied to look at how the data that is being received in all these domains are being visualized. So first one is a banking visualization. So here we try to make the customer communications more engaging as well as effective in nature, and using data visualization with your communications can be a distinctive advantage for your business. So the customer communication includes some statements, correspondence, bills, invoices and even advertising or flyers. The statements can contain financial information, cell phone usage, utility data or some kind of retail buying patterns. So in the case of banking application, we need to provide some way of interactive access to the statements. We also need to provide larger amount of data for reference for the customers, and we also need to provide cross-reference to data to other accounts and other external data sources. So these are some of the important key points that are to be noted in the case of banking visualization. So this is one example of a banking visual that has been drawn. So if we look at this visual, we can see that the Wells Fargo advisors are given, the amount that has been spent by the Wells Fargo advisors via brokerage has been given, and similarly for each and every area it has been divided and the amount has been specified. Similarly, in the right hand side here they have given the spending, that is groceries, what are the areas in which the amount has been spent, the groceries, travel, merchandise, home improvement. So we can compare these two charts by placing them side by side. Then in some cases we need to visualize the sequence and dynamics of the financial crisis. So in the next slide we try to illustrate the sequence and dynamics of the current financial crisis, including the major actors and factors in the crisis, from mortgage borrowers and lenders, the trade and mortgage backed securities and other derivatives, the government and the related agencies. So the full scope of this crisis touches nearly every aspect of the global economy, as we know. This highlights the growing bubble in the real estate values, bank assets, profits and trading activity and the subsequent implosion and fallout, including falling home prices, foreclosures, bank closes, bankruptcies and the bailouts. So the visualization shows the relative scale of the various elements of the crisis and the timing of the major events. So the visualization is shown here. This is a JP Morgan's asked to buy each and every product at some huge discounts. So here is a visual that shows JP Morgan's acts to buy the ailing Bear Stearns at huge discounts. So it has been visualized using bubble chart as well as using a bar graph. The next one is a government data visualization. As we can see, government also try to produce huge amount of data. So in the geographical information system is an important component in any government policy or delivery of government service, and in particular in the areas of public health, transport, education and program funding. Many state and local governments try to use the geographical dimension in the reporting environment of their business intelligence systems. So the visualization has to empower the public sector to extend the standard database and the business intelligence capabilities with visual graphical dimensions that enhances the data visualization, reporting and predictive analytics. Visualization with the location intelligence is capable of integrating the geospatial and business data of all types, say the transactional, operational, analytical and aggregated data from small to large databases and systems of records. So these kind of government data visualization helps in gaining a better understanding of the jurisdictional territory and the activities within that territory. They also build and consult operational and strategic dashboards. They help in visualizing the key performance indicators and measurement activities. We can evaluate the impact of public policies through various data analysis report. So this is a government data visualization. As we can see in the geographical information system, the amount of toxins that has been eliminated by each and every state has been shown as in a pictorial map. So the bubbles, the size of the bubble represents the amount of toxin that has been released by each and every state. So looking at the next data visual, we also know that the Department of the Defense is the only third largest egg, which is shown in the form of an egg in the federal government's basket of spending after both social security and the biggest debt and deficit contributor, the Department of Health and Human Services. So this is a egg diagram which represents how the money is being spent by the US government. So from this we can easily understand that Department of Defense is spending very less when compared to the Social Security Administration and the Department of Health and Human Services, which is going to spend a huge amount of data when compared to the rest of the departments in US government. So this is one kind of visual government data visualization chart that has been prepared. Next one is a insurance data visualization. Location intelligence brings the where factor to your analysis, helping maximizing the results in the case of market segmentation analysis, direct marketing and advertising campaigns, and sales territory analysis and strategies through a clearer understanding of the density and distribution of clients within a territory. Location intelligence solutions for insurance and banks also turn the data about customers, trade area and marketing operations into knowledge that provide greater insight into performance. So the insurance industry can make more informed decisions and gain a competitive advantage regarding the marketing actions, risk assessment, claim management and fraud detection. So this is one kind of chart that has been prepared which shows insurance agencies data which has been visualized in this form. This is insurance data visualization. Next one is a healthcare and medicine data visualization. So the above image that has been shown shows the results of the query of Duke Medical Center electronic health record system. The squares represent the top two users of the system. Here we can see there are two squares, so these squares represent the top two users of the system, and the circles represent the queries they initiated. The bigger the circle, the more the term was queried. So here we can see a bigger circle where we can understand that these kind of terms are the terms that has been queried the most. Light red lines connecting the query terms show the strength of relationship between these terms. There are light red lines which show the strength of relationship between the query terms. The green section shows terms used by both the users. So this section shows the terms that are being used by both the users. Here this is by user 2 and here are the terms that are used by user 1. This visualization was used on the existing data to better understand the kinds of queries made by users and see how the queries relate to each other, so that future visualization could aggregate data in meaningful ways. The next slide we can see a visual about the primary care trust in the UK. Here each axis on the circle represents a medical condition being measured. For example, a lung, bladder and colorectal cancer, and each wavy grey line represents a scores for each variable for the primary care trust. Dark blue shows a median measure of the occurrences of each condition. So here is a visual, dark blue is a blue which is shown here, which talks about the median measure of occurrences of each condition, and the thin red line is a measure for one PCT in a London suburb, which shows a low rate of all cancers except esophageal cancer. So here are the thin red line which is shown here for one suburb region. This visualization is meant to be more interactive so that a user can click on any one data point and see how a particular condition relates to other variables or which PCTs have that kind of similar profile. Data from medical records at Duke and Harvard are also being used to create a similar visualization system. So there is a kind of visual that has been drawn. The next kind of visualization that we are going to talk about in big data visualization is telecommunication data visualization. Telecommunication also amounts to huge amount of data that has been generated in day-to-day activities. So a framework can be used for creating the big data visualizations, especially in telecommunication domain where the volume of data is going to be huge. Also, it has to support the animations and interactions given the numerous dimensions of the data that is being analyzed, as well as the need to auto reload and refresh the data in intervals ranging from 1 minute to 1 hour. Creation of custom chart is a must to find the representations that suit most of the use cases to create a uniform visual and interactive data visualization across multiple applications and a wide spectrum of users in the telecom domain. So there is an area contribution. If you see the various areas are being combined together and it is shown here. So if you see the number of subscribers with high value subscribers, low value subscribers and everything are being shown as one single chart in the telecommunication data visual chart. Another perspective, that is a Tom Sawyer's perspective application, showing a visualization of a small network with a tree view of devices by location, table views of devices and connections, and an inspector view has been shown here. So this is a tree view of the telecommunication data that has been shown in the form of a tree view. Next one is a transportation data visualization. Transportation data also amounts to huge amount of data in day-to-day activities. So this is being shown in the form of a chord diagram. So the origin, the data is represented in the form of an origin destination matrix, and the chord visualization is shown in the next forthcoming slides. The chord diagram width by the chord diagram height represents the width and height of your diagram. Unit is in image pixels. There are trick mark scale which wherein the numbers shown on the trick mark will be the actual number divided by this trick mark scale. There are trick mark display units where after we set a trick mark scale, We may even want to show the unit of the scale to help the audience to understand the original number. Trick mark interval is also present, where the intervals are represented to show the trick mark label. So this is one kind of transportation data visualization that is available. So we have trick marks here, then we have the internal trips. We try to group all the trips. So we have a group name, we have a group total, we have a group separation, and we have trips from one specific area, say from Toronto to another one location. So similar to that, we have various trips that are being marked here, which are shown in the form of a visual. The next kind of visualization that we are going to look at is the capital market data visualization. Capital market, this is one example of capital market data visualization prevailing in one particular area. So the algorithmic trading is actually growing rapidly across all types of financial instruments, accounting to over 73% of the US equity volumes in 2001, given by Reuters and Bloomberg. This has been a fascinating research area at University College London, where for 8 years the algorithmic trading systems and an algorithmic trading risk platform has been developed with leading investment banks and funds. So the 8 years data set is being represented using this kind of visual. So this is the next kind of data visual that we are going to look at, is the asset management data visualization. So in asset management data visualization, we can see the amount that has been spent over time in various ways are being represented here in the form of a bar chart, and similarly by various category are represented in the by a pie chart. So we can have both the charts side by side, and we can do a perform a comparison of the time that has been spent. So Nick Hungerford helped create a UK-based online discretionary investment management company that emulates the slick UX, visual design and transparency. The company relies on data visualization to bring people closer to the money. It uses a similar visual experience of consolidating assets and simplify the process of setting up a fund as it guides the clients through the process. Some other examples of big data visualization. Chloropleth is one example of big data visualization. So wherein we can see the various regions and the number of participants that has been trained in various regions, and whether the project is not meeting the needs of educators in the region, or whether it meets the needs of educators in the region, or whether the project is likely meeting the needs of the educators in that particular region. Everything is being shown in the form of a color map as it has been represented as a chloropleth here. This is another big data visualization which is being represented in the form of a bar chart, a very simple chart. Here it is possible for us to compare the amount of data from the year 2010 to 11, the year 2011 to 12 and 12 to 13, which are represented in 3 different colors, and we can just compare all the data with respect to years. The next one is parallel coordinates. Using these parallel coordinates, it is possible for us to find out which sequence of data has got the maximum, or what is the kind of sequence of data which is going to appear most of the times. Is there any kind of sequencing which doesn't follow the other set of data or something like that? These kind of analysis can be done using the parallel coordinates. This is also another one, geographical information system, wherein state-wise it represents certain data set using the color coding patterns. So if you look at the big data visual toolbox, we can see that the volume, velocity, variety and veracity are available, and similarly the big data is usually stored in the cloud with the help of some kind of software as service vendors who will try to provide the kind of software as a service or storage as a service, wherein it is possible for us to store our big data in the cloud as such. These are certain big data analytics icons that are being used. These are certain examples of big data, so the big data visualization. The global private network activity is being shown here, wherein the high activity is represented and the low activities are also represented using various color coded lines. Here this is a natural gas pipeline analysis. So the amount of natural gas pipelines and things like that are being represented in the form of three-dimensional bar charts, and those are being visualized using geographical information system. This is an end-to-end risk analysis report with respect to each and every, the amount of funding that has been spent every year and the amount of risk that has been calculated for each and every year has been represented in the form of a three-dimensional bar chart. This is another visual which tries to show the telephone polling results, which in the discovery which is showing the BMS polling landscape. So along with the geographical information system, the telephone polling results are being shown using this map. So here on the line map, if we click on any particular area, it allows the user to drill down and see the results for smaller areas also. So this is similar to the previous cases. This is another one big data example where we can see the usage of Firefox, the usage of Evernote, and the usage of each and every software is being shown in the form of a star kind of visual. So if we look at the technologies that we use for big data visualization, although the data visualization product vendors seem to enter or leave the market with great frequency, several firms are beginning to develop significant brand loyalty. Redbrick helped the category managers in San Antonio to determine which products to put in which stores. Another application was the consolidation of 3 old data warehouses at Hewlett Packard. Oracle, a large suite of connectivity products, allows transparent access to mainframe databases. Some major customers include John Alden Insurance, Shopko Stores, and Pacific Bell. Informix, Associated Grocers, uses Informix data warehousing products at the heart of its 3-tier client server system. Sybase Warehouse works as an integrated system designed around the 4 key functionalities in data warehousing. Silicon Graphics, a data mining software, is mated to 3D visualization tools to allow the users to fly through the data. IBM provides a number of decision support tools in its information warehouse solutions. So if we see, it is possible in the case of big data visualization to present the data as well as to communicate the data to the end users. It is also possible in big data visualization to discover the data or to explore the huge amount of data that is being available. It is also possible for us to choose the visualization wherein interactively, based on the type of data that we are supposed to visualize, we can select the kind of visualization that we need to view on the screen. So in summary, if we, whatever we have studied till now, we have looked at the definition of what big data is. We have looked at big data visualizations. We have also learnt some of the domains in which the big data visualizations are very helpful, and at the end we have looked at certain examples of big data visualization. Thank you.